Okay, so we have been factoring and breaking apart quadratics for a week now. We're going to take it one more step and we're going to solve them, okay? So we are still factoring. We're still using slip and slide. Factor by grouping will show up, I think, a little bit. Tomorrow we're going to do complete the square and using square roots. All different ways. But now we're going to add solve for x, okay? Now we're going to add solve for x. So when we are solving for x, there is a reason why we're doing this, okay? There's a reason why we're taking it one more step, okay? What does a quadratic graph look like? Like a what kind of letter? Like a U.
A parallel, a parabellum, a
parabola. There you go. You were getting there. It is a parabola, right? A parabola is a U shape. It could look something like this. It could look something like this. Or it could look something like this, right? All different ways it could look. How are each of these different from each other? Where they are crossing over, our x-axis, which is the middle. This one's crossing over twice. This one just once. This one not at all. Okay? So when we solve for x, for any function you ever do, whenever you find x equals blah, 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 you are finding the x-intercept of that graph. That is what the whole point of solving for x is. You're finding the x-intercept. Okay? So we are going to start graphing next week. This is part of it. So this is kind of your little leeway into graphing. Okay, so we're solving for x, meaning we're finding those x-intercepts. Or they're called solutions. They can also be called roots. Those are all different ways to say x-intercept. Okay, but I like making sure you know why we're doing it. Not because I want to give you an extra step. It's because it's going to help you when we start graphing them next week. All right, so that's why we're doing it. Which means is factoring and stuff going to go away? No, it's not going to go away. We're going to keep doing it. We're mastering it now so we can build on it later. Okay? So, here we go. We're going to factor first. Okay? When we factor and solve, you will see that they are equal to 0. You'll notice on your homework sheet, a lot of them are equal to 0. They have to be equal to 0. Some of them aren't. Which means we're going to have to make them equal to 0 on our homework too. We're going to have to move stuff over, okay? Because think about it. We usually say y equals and then the equation, right? So if I have 0 equals the equation, I'm saying my y is 0, that's the x-axis, okay? So to make it equal to 0 is showing us we're finding what's on the x-axis, okay? So when I factor this one, we can do basic factoring, right? We can think what multiplies to give me -2, adds to give me -1. What are those numbers? A 2 and a 1. We'll start there, right? We'll start with 2 and 1. Now with the signs. Remember, this tells you that they're going to be the same or opposite. They will be opposite. Now, do I need to have +2 minus 1 to get -1? Or do I need +1 minus 2 to get -1? +1 minus 2. That's going to add up together. Okay. Last week, we stopped. Today, we're not. We're going to keep going. Okay. We have to find with what each x value is equal to. So we're going to separate them. So we're going to have x plus 1 is equal to 0. And we're going to have x minus 2 is equal to 0.
That line is perfect.
Thank you. It'll never happen again. All right. So on my top one, to get x by itself, what are we going to do? We're going to subtract 1 over. So here we get x is equal to -1. Down here, what are we going to do? We're going to add the 2. So now we have x is equal to +2. Those are the solutions, the roots, the x-intercepts, all those words mean the same thing, okay? If I were to graph this lovely guy, boop, boop, where would it cross the x-axis? At -1 and +2, and it would look something like this. Okay, so that is why we are solving for x. So you could start sketching a graph. Yes.
I know, like on the one where it's like, when you get like the two fingers, it's like 5x plus 1. You have to show your work for that. But if it's just like that simple, can we just like already simplify that?
Yeah. Yep. If you notice the pattern that happens each time, which there is a pattern, then yes. Okay. So that was a basic factoring one. What other kind of factoring did we do when we couldn't just multiply to get C and add to get B?
Slip and slide?
Yeah, we got slip and slide. That's going to come back too.
Oh, no.
I know. Woo! Excuse me. Oh, I tell you we're going to quiz on this on Friday? So Friday is going to be all the different factoring ways. And then the solving stuff we're doing today and tomorrow.
Every other week or every week?
It just depends on what the material is. Yep. Okay, so will I use slip and slide with this one?
No. Yeah. Yes.
Let's think. Can I take a GCF out? Can I move the 3?
No.
No, it's stuck there. So I have to use slip and slide to make the 3 move. Okay, so we're going to slip the 3 to the end, right? Or we multiply the 3 to my C on the end of it. This gives me x squared minus x minus 12. And we are still equal to 0 because we're solving. All right. This does factor. Because 12 is negative, we're going to have a positive and a negative inside. So what numbers can I get to multiply to give me 12, but somehow add to give me a 1? 4 and 3 somehow. So think, how do I want negative 1? Is it 3 minus 4? 4 minus...
3.
Okay, we want that 3, and we want to subtract that 4. Yes, 4 gets negative.
Now I put the 3 back down when you slide it.
Good. We have to make sure we slide. Okay? We did the slip. Now we have to slide. We have to divide the 3 back out. A lot of people would have stopped right there and solved for x like, oh, I'm done. No, you're not. Okay? You got to finish the factoring process. So we're going to divide 3 out of each of these. So now my factors are x plus 1 and 3x minus 4. Now we make them equal to 0. Yes. So we're going to have x plus 1 equals 0. And 3x minus 4 equals 0. So my top one, we will do what? Subtract it over. So we get x is equal to negative 1. There's one of them. How about this guy down here?
You gotta
Add 4 first. Then what? Divide by 3 to get 4 over 3. Does that look familiar maybe? Oh, look at that. Didn't we have 4/3 in there at one point? Magic. Boom.
Didn't you write as 1 and 1/4?
I mean, it would be 1 and 1/3.
Yeah, that's
But we're going to keep it 4 over 3. Okay. So if I were to graph this parabola, it would be crossing over where x is negative 1 and crossing back through where x is 4/3 or like 1.3-ish. So negative 1 and then like 1.3, like right there. Something like that. Yeah. When we actually graph them for real, we'll do vertex, the intercepts, end behavior, domain and range, my favorite.
Wait, what behavior?
End behavior. How the ends are behaving. Both of these ends are going.
Oh.
Ta-da! End behavior. It's just a fancy way to write it. Okay, so we're going with factoring and solving for x. Because now we're going to get into your favorite one.
Did you say so? Did you say so?
Dun, da, da, da. Okay, so listen, I know everyone hates on the quadratic formula, but there are good things. Okay? It always works. No matter what quadratic equation you have. Okay? Anything to the power of 2 is a quadratic. Quadratic formula works all the time. Now, we don't use it all the time because it is a little complicated. But if we cannot factor, like this one's not factorable. Nothing multiplies to give me 7 and adds to give me 4. It's not a thing. Okay? If it cannot be factored, if you cannot use slip and slide, if you cannot use the things we're doing tomorrow, which is complete the square and using square roots, if none of those things work out, grouping, quadratic formula will. It will always work. Okay? We could do that for the problem we just did and get the exact same 2 answers. Okay? So I know you hate it, but it is a nice little lifeline that you know you always have in your pocket if you need to. Okay? No, I'm not going to give you the formula. Yes, you will have to know it.
I know the song.
Okay? There are a bunch of songs out there. Okay? There are a bunch of different songs out there. If you're like, I want a song, go to YouTube and find Quadratic Formula song. There's lots to choose from. Okay? Mine's like the dun dun da 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 dun da dun. That one. Yes. All over to a yeah. So I was taught that in high school, and I'm still singing it. Every time I write it, I sing it in my head. So it's just stuck there. All right. So we have A's, B's, and C's. Where do those numbers come from?
Those numbers.
Those numbers. So where am I going to find A?
It's the X.
It's the X. 1.
It's 1, but it is in front of the x squared. So A is 1. Where is my C?
7.
Good. I thought I was going to trick you. C is on the end. And where is our B?
4.
B is in the middle with my x value, and it is 4. Good. Now, you are smart kids, and I know you are smart kids. But if you rush through this, you will make silly mistakes. Okay? So I suggest for you, when you plug numbers back in, to always put them in parentheses. Okay? Right now, they're all positive numbers, so we're more likely to not make a mistake. But when you're plugging in negatives, that's when mistakes can happen. Okay? So I will always suggest to you, and you'll always see me do it, I always plug them back in using parentheses. B squared minus 4AC all over 2A. I always do this first. Okay. So, negative B. What was my B? 4. Good. Plus or minus square root of B squared. So that is now 4 squared minus 4 times A, which is 1, times C, which is 7, all over 2A, which is 1. Okay. So, for some of you that might be annoying, but I promise it'll help the mistakes not happen as often. Okay. Now let's simplify. So negative 4 stays negative 4. 4 squared is 16. Yep. Negative 4 times 1 times 7. Negative 28. And then all over 2. Now we just got one little piece to simplify. What is 16 minus 28?
Negative 12.
So negative 12 over 2. All right. Before you start crossing things out and multiplying and simplifying and all that goodness, we have to simplify our radical. Okay? What is the square root of negative 12? Well, we can break it apart. For what and what?
4 and 3.
4 and 3. And also, don't forget that negative 1. Well, what is the square root of negative 1? Square root of 4.
2.
Square root of 3. It just stays square root of 3. Okay? So this becomes, negative 4 plus and minus 2I square root 3 all over 2. The I came from the negative under the square root.
Are you serious?
What I used to do.
We're going to start adding imaginary.
But wait, there's more. All the numbers on the outside, 4, 2, and 2, are all divisible by 2.
I used to love this one. I hate it.
Okay, I showed you a complicated one on purpose. Hey, they're not always this bad. I showed you complicated on purpose, so when it shows up on your homework, you're ready for it. They're not always this involved every time. Okay?
You won't have the I on.
You will not always have an I in it.
Because that's negative.
It's only because it's negative, yes. If you had a positive number in there, you wouldn't have an I to deal with. Okay? So we get x is equal to what? If we're dividing them all by 2?
-2 plus or minus square root
I
I 3.
I square root of 3.
No, it's just that.
And that's it. Excuse me. Now, well, quadratics, though, they always have two roots. They always have 2 answers. So why is that only 1?
Plus or minus.
Good. It is plus and minus. Technically, this is 2 answers. And you can leave it like this. I'm just showing you how it's 2 answers. Okay? That's -2 plus I root 3 and -2 minus I root 3. So those are the 2 different ones. So let me ask you this. If I were to sketch this graph, where is it going to touch my x-intercept?
Nowhere.
It's not. It's going to be one of those floating ones.
Not real.
It's going to be like that last one. It's going to float somewhere. It's not going to touch. So it still exists. It's still there. It's just not touching the x-axis. Okay? There. Got it? Questions on either of those before I go into discriminants? Okay. Now, listen to me. Listen to me. Guys, there is a way to predict what your answers are going to be. Meaning you can predict if you're going to have an I in your answer, if you're going to have 2 real numbers, or if you're going to have one number repeated twice. It's called a double real root. That one's real rare, but it happens, okay? The way we can predict this, if it's going to happen or not, is our discriminant, which is just the number underneath our radical, okay? So the b squared minus 4ac, that is your discriminant. Just that number tells you what your graph is going to look like and what kind of roots you will have, okay? So the b squared minus 4ac, not the square root with it, just that number is your discriminant. If that is equal to 0, let's think. If I have 0 under a radical, what is the square root of 0?
0.
It's just 0, right? That's only one answer. So that graph will only touch the x-axis one time. That's going to bounce off of it like this. It's going to bounce off like that. Let's slide that over. There we go. Okay. It's called a double root because if you were solving your quadratic, because quadratics always have 2 answers, you would get like x equals 3 and x equals 3. You would solve and get the same number twice is what happens. So that's the double root. All right. If our answer is positive under a square root, let's think about this. What is the square root of 9?
3.
And
3.
and
1.
what times what is 9? 3 and 3. But what else? Negative 3 and negative 3, right? Whenever you square root an answer, you always have 2 results. The square root of 9 is 3 and negative 3. Square root of 4 is 2 and negative 2, right? So when we do the square root of a positive number, we will always have 2 real solutions. Real solution means it's crossing our x-axis. Woo, like that. All right, to have a negative as a discriminant. Well, we actually just did that. My discriminant for the last problem was negative 12. That b squared minus 4ac from the last problem we just did. Look right here. Boom. Negative 12. So because we got a negative underneath that radical, my answers were what? They were not real, they were imaginary. So we don't have any real roots. Instead, we have two imaginary roots. So a negative discriminant means negative under the square root, which means we have to have an I. So they're imaginary. So it's not going to touch. It's going to float somewhere. Well, let's put it over here. Whee! It can touch the y-axis. It's possible. It cannot touch the x-axis. That's what it cannot do. Yeah. Would it make it feel better if I made it cross like that? That is okay, as long as it does not touch the x. Let me ask you this: is this guy a floating one with no roots? What if those lines kept going though? So be careful. Be careful. It has to turn away from the x-axis. Okay.
What if it was like going down?
That'd be fine. Yep. As long as it's turning away from it. Yes.
Doesn't it like keep going like out and out forever?
Yes. Yeah, so if there was like another one down here, come on, there we go. It looked like this, that would be okay. Because it's turning away from the x-axis. That would be fine. A little bit. Okay. So with our discriminants, when I ask you to find the discriminant, I'm not asking you to solve the problem. I just want to know what's the discriminant and what kind of answers are you going to have. Are you going to have two real? Are you going to have two imaginary? Are you going to have one double root? Okay. So I don't really care about what it is. I care about the type that it is. All right, so I think I have like two of these, and then I'll let you, then we'll talk about your homework, because there's some things I got to point out. All right, so the first one, find the discriminant and determine how many real solutions there will be. So we have x squared minus 4x plus 5. All right, so it says to find the discriminant. So I'm not going to factor or quadratic formula or any of that stuff. I am only going to do b squared minus 4ac. That's what I'm going to do. All right, so according to this, which one is our a? 1. What is b? Negative 4. What is c? 5. All right, so b squared is now going to be negative 4 squared. 4ac is now 4 times 1 times 5. All right, what is negative 4 squared?
16.
Yup. And then negative 4 times 1 times 5. What is 16 minus 20? Negative 4. That is our discriminant. So what does that tell me about the roots or the solutions to this graph? We're going to have no real roots. Instead, we have two imaginary roots. What will this parabola look like?
It's just floating by itself.
It'll be floating. It is not going to touch the x-axis. It's going to be turning away from it.
Isn't it going to go down?
This one will go up because x squared is positive.
Oh yeah.
So this one will be floating above it somewhere. So something, it might be like over here. Woohoo! Floating up there. Okay? And I don't care what they are right now. I just asked for discriminant and that was it. One more. Last one. Here we go. X squared minus 4.
Plus 0.
Nope.
Not plus 0.
Nope. Not plus 0. Now you know something's missing, right?
Yeah.
My X is missing. So what does that mean for my A's, B's, and C's? That means that my B is 0. Because we're missing that middle piece of the X. That means that my B is going to be 0. I know. I know. That's why I'm here to help you out. Okay, so we know B is 0. What is A?
1.
A is 1. Good. And what is C? -4. Good. Okay. 0 squared is 0. -4 times 1 times -4 plus 16. And what is 0 plus 16? Just 16. That's my discriminant. Now, I really don't care that it's 16. I care that it's what? That it's a positive number. Yes. So that means I'm going to have
2 real roots.
2 real roots. So what would this graph look like? Yep, it's going to go up, and it's going to cross over the x-axis twice. So it would look like this. Whoa. I pushed the eraser. There we go. So it would look something like this. Okay, you don't have to sketch graphs. I'm just showing you why we're doing it. So that's sketching a graph is not part of your homework tonight. Okay. Speaking of homework, I do want to talk about it. You are not doing all of it because it has all the methods on there. You're going to do 1 through 20 tonight, and then you'll do the last 10 tomorrow. Okay. All right. So look at the first section, 1 through 8. Okay. You have to factor, which means they are all factorable. Okay. You are not going to get any I's in this first section. The I's will not show up until quadratic formula, okay? So 1 through 8, no I's, all real numbers. You're going to factor. What do you have to do, though, to 3, 4, 5, and 6?
Equal it to 0.
You have to make it equal to 0 first,
You have to move the thing.
okay?
Yes.
Would you like me to do one of them?
Yes.
Like 5? Okay.
Do 5 or do number?
Okay. I'm going to do number 5. So 5 is 3n squared minus 17 equals 2n squared minus 5 plus 4n. Okay? To make it equal to 0, you have to move everything over. Okay? I like keeping n squared positive, so I don't have to divide by -1 later. So I'm going to subtract 2n squared to this side. All right. I also need to add 5 over, correct? That's going to get added to -17 because they're both constants. So those are my like terms. All right, but this 4n, I got to move it over by subtracting it. It doesn't have a like term, correct? So it's just going to be over here. There's no n. There's no n on that side. We're just moving it over. Okay? After I move them all over, we have to make sure they are in standard form. So start with my n squareds. 3n squared minus 2n squared gives us 1n squared. Then just my n, right? I didn't have an n. I subtracted 4n over, so I have minus 4n. Then -17 plus 5 is minus 12. Now it's equal to 0. Now you can factor it. Okay, so when I say move things over, that's what I mean. Okay. 7 and 8 on this worksheet, you have to do what? You still have to factor, but what kind of factoring? Slip and slide. Slip and slide happens for 7 and 8, not 5.
Oh.
Not 5. Yeah, no, 5 is a basic factoring one. 7 and 8, though, there are no GCFs. You will have to do slip and slide for those. Okay? 9 through 14, it just wants the discriminant and what type of solutions. Okay? So all you're doing is I would put it up there next to it somewhere. B squared minus 4AC. 9 through 14, that's all at once. B squared minus 4AC. And then what kind of answers? Do you have 2 real? Do you have 1 double real root? Or do you have 2 imaginary roots? Okay? And then the back, the last little section, 15 through 20, is going to be your quadratic formula. So you might want to write at the top of your paper right there also. This is where your eyes could show up. They probably will. And make sure on 17, 18, 19, and 20, you get 0 by itself first, and it is in standard form before you find your A's, B's, and C's. Okay? Sound good? All right, so 1 through 20 today, and then you'll do the last 2 sections tomorrow. All right, please work for the rest of the class.